All right, welcome everyone to the December 2019 meeting of the Mississippi PowerShell User Group. Tonight we have Lars Rasmussen with us, and he'll be presenting Building Always-On Availability Groups Using PowerShell. Take it away, Lars.
Thanks, David. So I know that we've got some folks in the audience who have varying levels of knowledge as far as the SQL Server part of this and what an availability group is, so we'll introduce that as well. This is a picture of me and my family. I've been working with SQL Server for a little while. Before that, I've worn hats as a Linux system administrator. I've done Exchange, I've done EMC SANS, and had an opportunity to be the junior guy on a DBA team a few years back. And I've stuck with SQL Server ever since then. But I don't know about y'all, but for me, seems like every job I've had since I started working with PowerShell, every job I've had seems to be an excuse to use PowerShell. So it doesn't seem to matter whether I was working with Exchange or SQL Server or other technologies. It was a good reason to play with it. There's my my contact information there if you want to reach out to me. When we talk, there's a few different parts that go into the availability groups, and Microsoft's picture of this is in a Windows Server failover cluster context, and in this case, they're saying, oh, you've got one place where you can actually write your data, and then you've got 4 other places where you can read your data. So these replicas, as they're called here, are sets of databases. It could be one database, it could be many databases, but they're mirrored between these different nodes in the cluster. One place where SQL Server exists is called an instance. So in this case, each node has one instance, and that simplifies the design here, and it allows for some load balancing so that you could read off of these secondary replicas and then write to the primary. So that allows you to have more clients that just have the read intent on them. And for what we're going to be doing tonight, it looks a little bit more like this. So it's we've got SRV1 and SRV2, and those will be our 2 SQL servers. And we'll have 2 databases right here in an availability group. So remember, again, an availability group is a group of databases. This availability group containing those 2 databases, once we get it all set up, there will be a separate IP that's called a listener. And that's the entry point, the virtual network name that moves between the nodes in the cluster in order to connect. One of the things that I've found in working with availability groups and databases is that there's often a need to change connection strings as you create new installations of SQL Server, or you decide to upgrade to the latest version of SQL Server. So one of the techniques that I've found that is helpful for not having to change connection strings as much is to use Cnames. So we'll add another layer, as you can see up top here. We've got the this little SRV, this Cname here, and that way, whatever the application developers need to put in their connection string, they don't have to do it more than once or change it later on. We can just keep that Cname in the connection string, and it kind of future-proofs it for us. So if we needed to do this again in a couple years, for example, when a new version of SQL Server comes along, we could build it out. There'd be different server names. There'd be a different listener name. But what we would ultimately do is just repoint the Cname to whatever the new listener name would be. Okay. Now, when you look in Management Studio, it looks a little bit like this, where you've got your primary and your secondary and the databases and the listener. So it looks a little bit different there, but this is all the same thing. I just want to make sure that people understand exactly what it is we're building tonight. And when you look in Failover Cluster, this will be our end state here. So if you look at the server name under the resources here at the bottom half of the slide, there's L-SRV, which is our listener name, and then it has its own IP address, and that moves between the nodes. In this case, if you look towards the top right of the slide, you can see that the owner node is SRV1. So SRV1 is where the traffic for the primary replica, where writes to the database would go to in that case. And that's going to be important when it comes to failing over, and we'll get to that a little bit later on in the presentation. There is also a health indication that you can look at. There's a dashboard within SQL Server Management Studio, and you may or may not be using SQL Server Management Studio, but this dashboard does give you some health information about your primary and secondary replica and all the databases that are contained therein. And so that's something that you can reach simply by right-clicking on the availability group and opening up the dashboard, and we get this screen. And with that, here's a URL for the demo, and it's also posted in the chat. Let's close that. So we've got a few different scripts here that we're going to be using. This first script, I kicked around a few different ways of putting it together, and I thought, well, I could use a parameterized function and just pass them in that way, and decided to use the built-in commandlets from two modules. The DBA Tools module, which is a great module. I've been using it for a little while, and I'm very fond of it. It's something that at work I use every day. That's at dbatools.io, and there's a section of links if you go to the demos that talk about the different resources that we'll be using today. One of those is this DBA Tools module. Another one is the SQL Server module, and we'll be using the commandlets from both DBA Tools and the SQL Server module. The environment that I used to create this SRV1 and SRV2 and the domain controller that comes with it, I got from PS Autolab EMV, and Pluralsight now maintains that. I think Jason Helmick originally maintained that, but it was part of another project called Lability, and so it's got some history behind it. I may not have all those exactly right, but what I liked about it is that I could get a server up and running very quickly under Hyper-V that gave me my domain controller and a couple of servers and a box that was running Windows 10 that had my management tools on it. So SRV1 and SRV2 are both running server core. Okay. And so that was from this PowerShell lab config, the second link there. Okay, so the first thing we've got here is a list of databases that we're going to include in the availability group. And then we're going to need to import the SQL Server module. That's just because of these variables right here. And we're going to pass a few different things here for domain server, primary replica, and so forth. This part right here on line 18, this is the service account that we'll be using to actually run SQL Server. So when I installed SQL Server, I specified that this was the account that I wanted to use as the engine account. And this IP right here is what we'll be using later on to create the listener. And this is the name of the listener. This is the Cname. It's kind of a boring Cname, so let's change it to something else here. And that will be what we use to connect to the server, because this Cname, this baby Yoda, will point to L-SRV, which is the listener, and then that's what moves between the nodes with the virtual network name. AG01 is just more of a functional name. That's the name of our availability group. We could call it whatever we wanted. It's not used in a connection string at all. But some people might want to have separate groupings of databases. They could have multiple availability groups. In this case, we just have one, and that one availability group contains these two databases on lines 6 and 7. And with that, we'll go to the second part of this, which is enabling always on. So that happens, let me scroll over a little bit to the right here. Right here, here's the commandlet, enable SQL always on. Now you can do this in the GUI, but we're going to be doing it just at the just with the commandlet in PowerShell, and it does require that SQL Server be restarted. So that's something you need to plan for in a maintenance window. Now let's go ahead and jump to the command line. Okay. So first we'll dot source those variables that we saw. And then we'll go ahead and enable SQL always on. Before I do that, I want to show the cluster, a live view of the cluster. There aren't any roles here yet. Those are also called cluster groups, kind of interchangeable, cluster group, cluster role. But we do have SRV1 and SRV2. For the eagle-eyed, you may have noticed that we have a file share witness. And in this case, I put it on the domain controller. You probably wouldn't do that in production. But here it made sense because I can have a share there that's outside of my two servers to handle quorum. And this roles portion will be populated as we build the availability group as we go along. So let's jump back to SRV1. So you can see this is HADR enabled. Flag is set to false right now, so we'll change that. And that's why it's giving us this error message, because it does require the restart of the SQL Server service, also known as the database engine. And enabling that, nothing's happened yet. We still don't have a role, but it has been enabled. You can see true right here, true, true for both servers. And the next part we need to do is establish a method of communicating between these two nodes. So, earlier on we were looking at the, I'll just jump to it over here. At the way we were going to set this up, we've got a couple of databases here. I'm going to use this in a different place, actually, because it's not very readable there. Let's go back to the slide for it. There we go. So you might remember we have the SRV1 and SRV2 and AG01. So in order to communicate between those two nodes, we have to choose a port that actually is responsible just for committing transactions to both sides. And we have to create an endpoint in order to do that. And it's called a database mirroring endpoint. And here's what it looks like in the script. I'm going to, first of all, output the existing endpoints so there won't be any there. Then we'll create some new ones. And this is where the port is specified. Now, if you wanted to use a non-standard port for database mirroring, you could create another variable back in the variable declarations and substitute that variable right here. I like to use the standard port for it. Once we create the new endpoints here with the new SQL HADR endpoint commandlet, we'll take a look at the status of them again, and then we have to start the endpoints, because when we create them, they won't yet be started. So let's go ahead and do that now. And I'll pause here for a moment and see if we have any questions so far from the chat or from anybody else. Okay, feel free to interrupt if anything comes up. So SRV1 and SRV2 don't have any endpoints. Then boom, we created two endpoints, one called HADR endpoint, another one called HADR endpoint. Here's the stop state, and then we started them. Okay, now we're going to need the databases, because these are fresh installs of SQL Server, so I don't even have any databases yet. So I'm going to use this new DBA database commandlet to create a database, which is fantastic because I don't even have to know T-SQL to create a database if I use this commandlet from DBA tools. So we created the My database, and we created the Your database. So the next step is to create the availability group. So again, we don't have any roles yet. All we've done is enabled the feature for the availability groups and created the endpoints that mirror between the two nodes in the cluster. So this is what the next part's going to look like. Again, we're just dot sourcing the variables here at the top. It's kind of like an old style include statement. Could have done that differently, and if you want to take this and run with it and parameterize it, that'd be a great option as well. So we'll import the SQL Server module, and then this part right here doesn't apply so much to a demo environment, but in a real environment, you're probably going to be using one sort of privileged account that has a sysadmin role on SQL Server to perform the setup. And then you may remember earlier on we talked about a separate account that actually runs SQL Server, this one right here. So when those accounts are separate, it's a lot more applicable. In this case, they're one and the same because we're using a domain account for a user called ArtDeco, whose username is ArtD, and we're going to create a login if it doesn't already exist, so that we have a way to for the endpoints to communicate with each other, and then we have to grant a permission to that account so that they can communicate in between each node. After that, there's kind of a templated build out. It's called an in-memory representation, as you can see on line 29, and I just splatted it. There are a few different options here. One of them is this line on line 37, the failover mode. When you do a synchronous commit, that's going to be an automatic failover, but you could do an asynchronous commit and have a manual failover, in which case this wouldn't really give you HA, but it could still give you that load balancing to offload reads and writes to different nodes, or if you just wanted to use it for reporting, you could use it for that, and it could be a little bit further behind, but you wouldn't get the HA benefit. Typically in production, I'm using this setup that you see here, where you have an automatic failover and a synchronous commit. It does require that the transactions get committed to both sides, and you get the acknowledgement back from both before it is all done. So the other part I want to call out here is the seeding mode. We already created two databases. Remember, we had your database and my database. Typically, until I think it was version 2017 of SQL Server, it might be 2016, you had to restore a database to both sides, so it had to exist. We created it, but we have SRV1 and SRV2. So right now, that database only exists on SRV1. We are going to avoid restoring to SRV2 by using what's called direct seeding, and that's the seeding mode equals automatic, where we just let the server handle that by itself. My experience with this has been that you probably don't want to try to seed more than several hundred gigabytes. If you're talking in terabytes, I wouldn't do it. If you're talking about seeding several small databases, that's doable, but I wouldn't do more than about 4 at a time in a loop. So first of all, these are the primary replica. The primary replica properties that we have here, and then we have the secondary replica properties. And you can see the port number there, again, is specified for the database mirroring endpoint. After that, we go ahead and create the availability group, and we have a confirmation statement here, and name of this kind of a final little sanity check. Hey, you said the AGU name was going to be this. Is that what you want? Yes. Are you sure? Etc. So let's go ahead and jump to that. So we'll say yes to all. And this cannot grant denies what I was talking about with the different users, because I'm trying to grant something to myself. Typically, they'd be separate accounts, but in a demo environment, it makes more sense. Now, we can see that we've got some errors that cropped up, some blood on the screen, if you will. This is, I let this come up here on purpose because this is a common mistake that I've made and I've seen others make. One of the things that you have to make sure of, even with direct seeding, is that we have both full and transaction log backups of our databases before we can seed them. So we created those databases. Remember, we used that new -dba database commandlet, but those databases haven't been backed up yet. So that's why that creation failed. So what we're going to do now is use some scripts from a very talented man named Ola Hallengren, and it's called the SQL Server Maintenance Solution, and it has scripts for index and statistics maintenance and backups of SQL Server, as well as integrity checks of the databases, both your system databases and your user databases. So we're going to install those scripts and put those on both nodes, SRV1 and on SRV2. And another thing that we want to check here is we already have the database engine running. We know that because we were able to run some commands successfully previously. But we need to make sure that if we're creating jobs, you might have noticed this install jobs parameter, switch parameter, If we're creating jobs, we need to make sure that SQL agent is also running, because a fresh install of SQL Server, a lot of times the service will be set to start automatically, but it won't yet be started. So we're going to take a look at that. So sure enough, you can see that the state is stopped. So we're going to start those services. And verify that. Okay. Now let's go back here to our cluster view, and still no role because we haven't created the AG yet. Okay, now we can see the jobs that we have. So when we did that, let's jump back here, this install DBA maintenance solution commandlet, when we ran that, it created these jobs. So here we've got our database backup for system databases and user databases and so forth, the 3 different types of backups. And we need to run a full backup, this user database backup. And we also need a transaction log backup, which is the one underneath it, user databases log. So we're going to go ahead and run those now. That's what this start DBA agent job does. And then we can check, make sure that it did run. You can see right there, last run outcome was succeeded. So it just ran. And the timestamp on this server is 2 hour offset from the corner of my screen here. This is my time, but we've got a different time zone on the server, so we're okay. So we'll go ahead and start a transaction log backup. And now we'll try to create the availability group. Yes, we're sure. Oh, there it is. You might have seen it pop up there on the cluster. Now we have a role. That role doesn't have any resources in it other than the availability group itself. It's kind of a placeholder. So the next thing we need to do is create a listener. So the listener, if you remember, I'll jump back to the diagram here real quick. The listener is where we decide, hey, this is what port we're going to listen on for incoming client connections to the database server. Not to be confused with the database mirroring endpoint, because the database mirroring endpoint, all it does is handle these synchronous commits between the nodes. So that handles mirroring of the pages, but it does not provide a way for us to get into the database. That's what the listener does. So we'll have to tell it, we'll have to tell the commandlets that we run which port we want to listen on and what the IP is going to be. So let's jump to that script. There's our port number right there. We're going to use the default SQL Server port. And here's our IP and the subnet mask. And remember, we set those back here. So that's going to be our IP. And then this variable, AG listener short name, is going to be the name of the listener, L-SRV. So let's go ahead and run that. Yes, we're sure. And then we got another error. And again, I left this error on purpose because this is another common pitfall, gotcha, if you will, that is very, it is just that, it's very common, that you'll have to take care of. This has to do with permissions in Active Directory, having create computer permissions for the virtual network name of the cluster. So let's go ahead and fix that. So I don't know of an automated way to fix this part yet. And usually my sysadmins will have this already set up for me, so I don't have to worry about it. But I'm going to show you what it looks like, just for the purposes of the recording and in case you ever run into it. We're going to right-click on the OU that contains the virtual cluster, the cluster virtual network name, which is the CL-SRV. And then we're going to choose Delegate Control, and then we'll add that account. And create a custom task for that. We want computer objects. We want to be able to create selected objects in this folder. And we want to be able to read all properties. So let's go ahead and finish that. Now let's come back and try this again. Went one step too far. I'll have to come back. So let's try to create that listener again. And I'm going to bring up the failover cluster so you can see in the resources here. You'll see the listener appear. Just all. There's our IP, there's our port, and then poof, it's offline, online pending, and online. So there's our listener. Our listener's been created listening on port 1433 at that IP address. Okay, the next part we want to do is to create the Cname so that we have those feature-proof connection strings. And so you may have noticed that I ran a script earlier to add some features for DNS, and I'm running that again here, so that's why it's saying no, I don't need to do anything because you already did this. We'll import that module. In this case, our DNS server is the same as the domain controller, and then we'll create the Cname. And all these commands that I'm typing are contained in the repo. So if you want to just go on GitHub, you can see every single one of them. We're referencing, again, the variable names. Okay. Now let me jump back to the cluster parameters. This URL on line 7 talks about why you'd want to change some of your cluster resources in an availability group and have these specific parameters. So you can dig in there if you want some detail on it, but it mostly has to do with these lines on lines 14 and 15. So we actually have to stop the cluster resource in order to do this. So if you watch, you'll see it go offline here. I'll move it over to the side a little bit. So it was really fast to change those and bring them back online, but it does take the cluster resource offline. But since we're setting it up for the first time, that's okay. Now we're going to check and use this is kind of like an NS lookup command. Let this resolve DBA network name. So let's take a look at the listener first of all. Okay. So there's our listener name, that variable right here, resolved to this L-SRV, and that is resolving properly to the IP. And right now, the owner node is SRV1, so that's the DNS host name that appears. Now let's take a look at the AG listener Cname. So this one, you may recall, we were using that a little bit earlier. We customized it. We called it Baby Yoda, and then Baby Yoda is indeed resolving to DNS host entry L-SRV on our domain. So those look pretty good. That's exactly what we'd want. So at this point, we have a functioning availability group that we can connect to. But one of the things that often comes up with an availability group is how do I take a look and see how quickly it fails over? In case of emergency, what are the timeouts need to be set to for my clients? So I can, how soon will it come back if something does happen to one of those nodes? I shouldn't say it comes up often, but it is one of those things that's good to know. And so I'm going to open up that script and we'll take a look at that real quick, how we would test the listener failover. What we're doing is just having a timer here. So we have a get date, that's a start of our timer. And then this is the failover. We're invoking failover right here with the move cluster group commandlet. That's what we're piping to. And then we're saying, while we can't connect to the listener, while we can't connect to the Cname, sleep for 100 milliseconds. So keep doing that. I can't connect yet, so wait. Can't connect yet, so wait 100 milliseconds at a time. But keep trying. And then once you are able to connect, then at that point we'll do a kind of a hello world. We'll use this invoke SQL CMD, and this part we're just going to select an internal property of the server and show some uptime there, the name of the server, and a few other basic pieces of information about the server. Then we will take a look at the status of, we have those two databases in our AG01, my database and your database, to see the synchronization status. And then at that point, we'll stop our timer and output the duration to see how long it took. So we went offline, changed to server 2. Okay, we got our query back, and it looks like that all told that took 15.5 seconds to run. So that's pretty good. We've got a good failover time here. I could have a 30-second connection timeout, and I'd be able to have my clients reconnect in plenty of time. So we've successfully tested at this point. And taking a look here, you can see that we failed over to SRV2, whereas before we were on SRV1. So that is a successful build of the availability group and testing of failover as well. So with that, I'll open it up to any further questions. Okay. Not hearing any questions yet, so I'm going to jump back to the repo. So when you take a look at it, you can see the overview of what you're going to create, and there are some links here that I referred to earlier for that PS Autolab environment module. There's a little bit more than that too. This right here shows how I installed SQL Server. So you can take a look and see what happened before even installing SQL Server. I changed the default shell, I changed some things on the firewall, I changed the power profile, I disabled Windows Defender and a few other things. And that's how I did that, was using this script here. So if you want to go back through and create this lab for yourself, you've got plenty of resources to do that. And if there's anything that you find that's missing or unclear, feel free to ping me on that, and I'll add it to the repo. And that concludes our demo. Thank you.
All right, thank you, Lars. That was a good presentation.
It's something that I've done in production several times, and this was originally one big long script, and so I just tried to chop it up into a few kind of logical chunks, bite-sized pieces, if you will.
Looks like we might have a question or two. Just
Okay.
keeping an eye on the chat here.
Yeah, so that you broke it apart into different groups, that you could use part 3 there to like add 3, 4, 5, additional, what's the term, replica you said, to the AG.
Yeah, you could. If you wanted to have multiple secondary replicas, you could customize those scripts to do that. What we did here was just a simple, 2-node, having one secondary replica.
Yeah, so we just need to add more stuff into like third script, and then it would just do it that many more times. But effectively, the whole thing is still, the rest of the AGs and the are still the same, right?
Yeah, each node has to have an endpoint. And you still have a single listener that controls where the connections go. And that listener, according to what the connection string asks, you can have parameters in the connection string that say, hey, that I'm only going to, this is a read intent, I'm only going to read data. Or, no, actually, I'm going to be writing data. And the listener will direct the client request to the appropriate node.
Okay, so that's done at the client, at the request level.
Correct. The connection string is going to define that. And then it just gets routed by the listener effectively.
Cool. Yeah, it seems real easy.